What we could do with that,
we're in business here.
We could have like the water.
You know, working hard.
As the.
Oh, it does beep when you go.
We're recording our work right now, working on brainstorming a problem for water quality. This is what TechSmart is about. Why don't you just, instead of using the fill tool, just get the brush? So we are now on basically the plan, design, or intended objective of your innovative app.
So we just presented them with a challenge, an innovative app challenge. And students, having had experience in designing apps or having obviously used apps, students really took to that. They given the opportunity to dig right in.
It'll be like all blue and stuff, and I mean we'll probably like do it on paint or something, so it looks nice. Like, 'cause that actually looks good.
Like a little introduction to the game.
Before we even told them what the challenge was, they heard app, they heard water quality, and they just hit the ground running. So I think the fact that they got to, put their own creativity in it and make their own graphics, make their own interface for their potential design, they really took to it.
Come back later.
How large
Here we have Eddie playing Clash of Clans.
You know how to
Actually, we need to look at this for our app, so...
Just turn it. Okay, now it's recording this.
It's definitely a challenge for me and the students, but it's one of those things that I think they're going to look back and say this is one of the best things they've ever done. I love teaching. I love teaching back at the high school, but the work that they do here at TechSmart is really hands-on work and project-based work that relates to, I guess, the skills that they're going to need to be successful as people when they get out of high school.
Oh, what's up? Hey, how's it going? Dude, I can't walk upstairs.
Hello, my name is Jillian Zick, and I am extremely lucky to have such a supportive team of people behind me. This team includes my kind parents and friends. Whenever I need help, they are always there to lend a hand.
They're all basic.
Hi, my name is Zach. My mom is one of my leading motives to excel. When I handle my chickens, it fills me with excitement and makes me want to reach for even more last year's goals.
And it was really our pursuit back in 2010 to create learning environments that are problem-focused and gave kids real hands-on opportunities for teaching and learning to solve problems and be able to apply knowledge in the real world.
I'm not.
I'll say bad things. I will say bad things. Do not make me say bad things. I will say them.
The water quality project, every project that we design here at TechSmart is about a real issue that faces our community and getting the kids to understand all the factors that affect those issues. In the water quality unit, we start by helping the kids understand the water quality within their community, what is a watershed, what water bodies exist within their communities, and then what's threatening those water bodies, or what might be, what are we doing that would help, protect those water bodies. That week, unfortunately, was really rainy, so it was a tough time, but I said to the kids, make sure you're ready to go. If it's raining, we're still going. Have your boots, have your rain jacket, and whatever you need to stay warm. So, they were troopers and they made it through it, and we got down through there. And we went to several locations: Kelly Park, Arrowhead Lane, where the mouth of the Cateros goes into Saratoga Lake, and a couple other locations up in Rock City Falls.
Our schedule's pretty straightforward. 1, 2, 3, 4, 5, 6, 7, 8 every day.
So they get an understanding of, okay, yeah, these are the factors that might affect the watershed in a negative manner, and this is what we can do to help benefit it. But then there's still that understanding of, okay, what does it mean to have that water right in front of you? So that's why we do take the field trip. But before we take them out there, we have to have a purpose, other than just going out to see the wilderness, because it is great to get the kids out there. We want them to understand what's done to test the water. What are some of the parameters that we look at to determine if the water is healthy or not, or if it's impaired is the term that they use to determine if a water body's negatively affected. We'll assign parameters to each group of students so that one group becomes an expert in pH or dissolved oxygen or turbidity, and then they know what they're looking for when they go out into the environment or the watershed that we go to. We took them to the Cateros Creek right here in the town of Malta, and we took them to several different locations. So when we do that, they get a real, familiarity with the water that exists in their location, because a lot of the students that we have are from this area: Mechanicville, Stillwater, Malta, Ballston Spa, Wilton, and they're from further reaches as well. But when we take them to a water body that they really, haven't explored that much, or some have, they seem to be a little bit more invested in the program and the activity that we're working on. For some reason, they take on the responsibility, for owning that watershed. Not all students do, but certainly many do, and they gain a stronger appreciation for it.
Give him the stick, the magic thing.
When we went out that day, the students had the testing equipment, and they gathered samples. We took a water sample from the center of the stream and then pulled it out and used the samples so that the students could test their parameters individually. And they did a great job, trying to figure out what they had. They had to do several tests to understand what they were looking at. And there was calibration that was involved with the equipment, because, as we know, anyone that works in the field, it doesn't always go as planned. So students were frustrated at times when they get the equipment in their hands and it's giving them a foul reading that just doesn't work, and that's part of the whole process.
Think about stream quality. What could be influencing the quality of this water in this area? From litter. Okay, we certainly could have plastic. If we put plastic in the water, well, if we put plastic in the water, is that going to affect the water quality?
As they grow up and get older, they start to realize, yeah, I remember going there with Mr. Glagowski, Mrs. Lewis, and Mr. Ballet, and we talked about that. And I think when it comes up in the town meeting about water quality, they're going to be able to tap into that knowledge later on and say, yeah, this is important, because it is hard for students to recognize the importance of water quality, and how dynamic of a topic is that? When you really present it to students, water quality, okay, great, but to get them to fully understand it, I think it's got to be in their real world somehow.
Hey, Cole.
Who wants to explain?
Long time no see.
Who wants to tell me what's going on here?
Gavin and Bender.
They're so beautifully fanned out. You got lifesavers. I'm going to take one of those. Or two, apparently.
Well, now our presenters.
November 5th, we had an expo for all juniors, seniors, and freshmen in the program. The expos occur about once every quarter, maybe 3 times throughout the course of the year. For the juniors, this is their first real exposure to a real audience. So everything we do in the program is talking about, build something for a stakeholder, design a new process for a stakeholder. So it's the first time they've had a chance to experiment or experience the fact that these people they're presenting to could potentially be stakeholders.
The game works is you start out with one factory and you choose your product, and that chooses the difficulty of the game. The more difficult it is to sell the product, the harder the game is going to be. As you sell the product, the more money you make, the more factories you build, the more water you make.
The products that are here are all carbon-infused products. The arrows, the bow, and the broadhead itself. The bow, well, the arrows to start are carbon nanotubes that are laid in parallel to each other, running down the length of the shaft, and then they're wrapped in a hypotite epoxy resin. This resin, mixed with the carbon nanotubes, causes a hybrid material to be formed that has not been made before. This new hybrid material is stronger and lighter than other materials that are out there, and when being laid into arrows, can be wrapped and funneled into the channel, and then it causes an arrow that has less fixation and is stronger, and then also it has a smaller diameter in the end it can be laid through. But with the smaller diameter comes a great range of advantages of this arrow. It allows it to pierce through a product, through an animal more when firing, or a target, whatever you're firing at. It allows it to experience less in-flight vibration, so when it's flying, it's not going to wiggle and wobble and deteriorate from its course and hit something else. And then with the broadhead being on the end, that's coated in carbon nanotubes running down the ends of its spines, it allows it to pierce through an animal, causing it less harm to the animal itself and less pain, and allowing it for a quicker, cleaner kill.
In the course of the year, we teach the engineering design process. And so we think of it as a cycle, right? You brainstorm and you think about a solution. You prototype, you test, you model a solution. Then you go, the third phase is to seek out feedback from stakeholders and redesign and re-innovate. And then the fourth step is finally, ultimately display what the finished product is. So during the expo, we give them the opportunity to do that third phase where they're interacting with a real audience and getting actual feedback, documenting the feedback. So at the next expo or the next interaction, they can really do well in that fourth stage, which is finalize, present, and really hopefully implement some of their solutions. So really we're focusing on giving students that opportunity to get live, real feedback to re-engineer what they've been working on.
Okay, our product is night vision glasses. How our product works is there's a thin layer of graphene that goes over the glasses that's only 1 atom thick.
Now what's graphene?
Graphene is just simply carbon that's laced together very thin and very strong. One sheet of graphene that's only 1 atom thick can hold a whole elephant standing on a nail, like they could balance on a nail. But one of the properties of graphene is that it absorbs infrared light and transfers it back. So what could happen is the graphene could pick up infrared light and put it back to OLEDs on the back of the lenses and create an image on the back of the lenses or contact lenses. So it could help you see in the dark. It could be on prescription lenses or reading glasses, sunglasses, anything could help you see in the dark. It'd just be a treat when you put it over.
So it's like night vision sunglasses?
Yeah.
Or contacts?
Okay, so with the military, their night vision goggles can cost thousands of dollars, whereas we are putting these towards a consumer that has $200 to spend. So we're reaching a wider audience.
Non-point source pollution, which is like rain runoff. So like the runoff from asphalt, shingles, fertilized land, construction sites, concrete, anything that's really made from toxic materials will go into runoff. So what our app was going to do is going to have a scenario where these runoff collection pits that would take about like 10 or 15 days to fill up with runoff, and then once the runoff pits were full, we were going to create a pipeline. And the pipes are going to be made with questions and answers. So the user is going to be questioned about topics related to non-point source pollution.
And the more they get right.
Yeah, the more they get right, the more links are built onto the pipe. And the more they get wrong, the more links are destroyed to the pipe. And if you get enough wrong, the pipe breaks, it goes into a nearby lake, pond, or river, and you got to deal with the consequences.
And that's when we have the expo and they're talking about water quality. They've got people that, I guess, town officials that are dealing with these issues right now. And when the students start talking about it, those town, if they have that interaction, the students, they gain an appreciation for it. Not the full appreciation that I think they'll get as they grow older and they buy a house and there's no water on the property. Then they'll really start to understand it, you know. And I think that's when I think they're really going to get it, is when it becomes an issue in their life that they have to deal with.
To put them in a situation where they have to present an idea to an audience, maybe as someone they've never met before. It could be someone in education, someone in industry. The fact that they're put on their feet and they have to articulate what they've designed, what they've worked on, it gives it that real authentic flair that students otherwise would never get until they're out of college. And it really gives them sort of a starting ground for that experience.
Our product is a German-based company called Tec, and they created an oil, like sort of like a motor oil. They've used nano beads into it, so it reduces temperature by 20%, reduces friction by 33%, roughness by 50%. So basically, you put in cars, motorcycles, wind turbines, boats, anything that has metal to metal contact, and it'll increase the space between the metal and metal gears. So it makes the gears last longer, so that there isn't many like maintenance checkups. So it's just saving money.
They one, take with them different experiences that they wouldn't have had anywhere else, and it opened their eyes to, hey, if I go down this road, I can do this. If I go down this road, I can do that. Things that they might not have seen in a traditional setting. Two, and most importantly, which I think that they will take with them, is the excitement for learning, and that's something that we see that a traditional system can sometimes extinguish. We see kids thriving in this type of environment, and the excitement for the work that they're engaged in. They take that with them as they move to higher education, as they move to the workforce. The excitement about the learning and the work and being engaged in that kind of work, that will certainly help promote their success as they move past high school.
This is the Carbon Tec two-piece carbon fiber football pad system with OS technology. It's 10% lighter, 20% stronger, gives you full range of motion, and it reduces pain from hits, it reduces injuries, and there's actually a helmet too. It greatly reduces concussions with all the news of brain injuries and everything in the NFL, NCAA. And they're a little expensive, but they have all the high-end materials, aerospace-grade carbon fiber, automotive-grade foam. And yeah, they're really...
So it'll reduce the frequency of injuries in players?
Right, yeah, it would greatly reduce brain injuries because due to the impact force redistribution, you might get hit in one spot, but it feels a lot less in one spot. It redistributes it so well that you don't feel it as much. It reduces pain in one spot. That's how you get a concussion, is when your brain moves inside your head. But if you don't feel it in one spot, then your brain can't move.
What surprised me is you see the students day one, and they're quiet, a little bit meek in some cases, but they completely come out of their shells. They gain such confidence as they go through this. They're out in front of their booths. They're talking to the people that are coming around from various industries and schools. You wouldn't have seen that day one. They would have been behind in their shell, behind their booths, and pointing to their displays rather than really articulating and explaining what they've worked on.
It essentially has created a culture in and of itself where risk-taking is okay. It's okay to be myself. And what you don't see in schools very often that we see here is everyone's learning along the way. The kids share in success, they share in disappointment, but they're always about getting better, and they've developed a real culture of collegiality and camaraderie that you see horizontally across the students, and you see vertically with the interactions with the teachers and the students and the administrative team and all of our business partners. And I think that recipe is really about how the work occurs here, promotes that kind of collaborative environment. But it's about the journey along the way, and that journey is really where the learning occurs here on this campus every day. The journey with the interaction of the students and the teachers, the journey with the interactions with the teachers and the students, with higher education, and with real world industry partners. And throughout that journey, we get to an end product where what Hewlett Foundation refers to as deeper learning, where we're not just talking about content, we're talking about applying content, we're talking about problem solving, we're talking about doing it from a transdisciplinary perspective. So we see encompassed in all of the students that are here this real inquisitive base look at how things can happen in their world and how they can drive solutions from what they're learning in classes.
I switched careers to go into the teaching career mid-life, and it's been the best decision I've ever made, because I really see myself in the classroom working with the kids and helping, I guess, grow the workforce and the people that we're going to live with for the next 50 years. I spend a lot of time with the kids, not only just training them about the science concepts, but also building those 21st century skills and collaborative skills that they're going to need to be successful, not only in college, but in the careers or whatever career that they may have in the future.